Lecture series, Climate Change, Moving from Science to Solutions, sponsored by the Wilderness Institute and the Center for Ethics here at the University of Montana. I'm Lori Young, I'm one of the coordinators for this series, and I'm happy to welcome our speaker for tonight, Tom DeLuca, whose talk is entitled Adapting to Climate Change, the Importance of Wilderness in an Uncertain World. But before we introduce Tom, I have a few brief announcements. First of all, I'd like to thank the Dana Gallery for generously donating artwork for series posters. And second, I just want to remind you about our next speaker, Tri Robinson, author and pastor of Vineyard of Boise. He'll be joining us on April 1st, and so we do not have a lecture next Tuesday, which is spring break. So please join us 2 weeks from now. He's going to talk about biblical responses to climate change. It's my pleasure to introduce Martin Nye, who will be introducing Tom DeLuca. Martin is an associate professor of natural resource policy in the College of Forestry and Conservation. Tom, as you know, used to work in the College of Forestry and Conservation with us. And, Martin knows him well as a former colleague, and is going to share a few bits of Tom's background with you tonight. So welcome, Martin.
Sound okay? Yeah. All right. Well, it's an honor to introduce my good friend, Dr. Tom DeLuca, this evening. Tom is a senior forest ecologist with the Wilderness Society, a non-government organization whose mission is to protect wilderness and inspire Americans to care for wild places. Prior to joining the Wilderness Society, Dr. DeLuca was professor of forest soils at the University of Montana and remains an adjunct professor at the university. I must say that he continues to be missed by his friends, colleagues, and students in Missoula as he brought in electricity, attitude, and a healthy dose of nitrogen fixation to the College of Forestry and Conservation. Not a lot of professors, for example, are able to tear off their lab coat and button-down shirt in the middle of a lecture and present a spandex-clad, cape-wearing super soils man to a group of very frightened sophomores. Dr. DeLuca also serves as a guest professor in the Department of Forest Ecology and Management at the Swedish University of Agricultural Sciences and is an affiliate professor in the Department of Land Resources and Environmental Sciences at Montana State. He holds a PhD in soil microbiology and biochemistry from Iowa State University, an MS in soils from Montana State, and a BS in natural science from the University of Wisconsin-Madison, the state in which Tom was born and raised. Now, this rooting in Wisconsin deserves a few words. Not because of all the fun jokes we could tell about that place. No, that would be inappropriate. And second, Lori was adamant that I keep this introduction brief. But it does deserve note that two conservation legends hail from the state of Wisconsin, John Muir and Aldo Leopold. And it is quite easy to see similarities between Muir, Leopold, and DeLuca. Tom, for example, is renowned for his intense, fiery temperament, just like Muir. And while Muir is known for his legendary walks, requiring some sort of extra human lung capacity, Tom is famous, and more likely resented, for his place among the elite cross-country skiers and runners of Montana. The difference, of course, is in the spandex. The similarities with Leopold are easier to draw. Not only did Leopold have a fascination with all things soil, but he left his mark by connecting conservation, science, and ethics. For Leopold and DeLuca, studying natural processes in isolation from the social, political, and ethical world around us is insufficient. Tom, it seems to me, is one of those acclaimed scientists that took Leopold to heart, and it is hard to argue with the consequences. Over the course of his scientific career, Dr. DeLuca has studied how natural and anthropogenic disturbance influence C, N, and P cycling in forest, prairie, and tundra ecosystems. Areas of emphasis include sustainability of soil resources as influenced by land management, fire ecology, biogeochemistry, forest restoration, and ecological benefits and limitations of biofuel development. Tom is the author of over 60 refereed publications, including contributions to Nature, Science, and this last month's cover story in Frontiers in Ecology. He is an elected officer in the American Association for the Advancement of Science, an active member of the Ecology Society of America and Soil Science Society of America, and the Union of Concerned Scientists. It is my pleasure to introduce Dr. Tom DeLuca.
Okay, is that working now? Sounds like it. Thank you, Martin. I'm sorry to say I came off without the spandex today. If I knew that was coming, I would have asked for a James Brown introduction. I would have thrown off the coat and slid across the floor, say, I feel good. But I'll skip that tonight. Let's see. Just to kick things off, 2 years ago, I left here for kind of an uncertain future, leaving behind a tenured position here at the University of Montana, but more importantly, leaving friends and colleagues whom I miss very much. And I feel honored to be here tonight and to have the opportunity to speak to you all. And it's an honor I would have never have gotten as the dirt scientist at the University of Montana, but one that I certainly appreciate today. And it reminds me that I'm not so far away from the University of Montana and that I still have bonds here, and I appreciate that. So with that, tonight I'm not going to talk about specific research that I'm conducting currently with the Wilderness Society, but rather talk more in generalities. But it was my understanding I was talking about biblical references. No. Oh no, okay, no. I'll skip the biblical references tonight too. But to kick things off, one thing that is constant in nature is change. It's probably the only thing that's constant in nature. Ecosystems are constantly faced with change, and natural ecosystems bend to fit these new conditions. Managed ecosystems, those that are managed by human beings, tend to be built to resist change. It's a fundamental difference between the way the two function. This sort of rigid approach to dealing with change certainly works in a lot of instances, and we'll talk a little bit about that later on. But natural ecosystems adapt to change, are resilient of change, and that is something I'd like to focus on tonight. Resistance to change may prove to be catastrophic failure in the face of long-term significant changes outside of the historical range of variability. And that is another thing that I hope to talk some about tonight. The objective of the talk tonight is to discuss adaptation to climate change and the role that wilderness lands and wildlands play in this adaptive role. Managed ecosystems, land preservation and ecosystem restoration will prove to be invaluable in the adaptive strategies to ensure the survival of the greatest number of species and avoid whole-scale collapse of our ecosystems. Speaking of collapse, in Jared Diamond's book, Collapse, the book Collapse by Jared Diamond, he laid out an elegant but simple 5-point framework for the collapse of societies, and then goes into detail on the collapse of multiple different societies, ancient civilizations. He said that basically it was a combination of environmental damage, climate change, hostile neighbors, friendly trading partners, and society's approach to environmental problems being flawed that would lead to the collapse of a society or civilization. Well, let's talk about where we're at right now in our society. We certainly have experienced inadvertent damage to our ecosystems, as well as intentional. Yeah, thank you.
Keep going.
I'm underway.
Just a little bit of
Okay. Okay. We certainly have experienced inadvertent damage to our western forests, rangeland, and grassland ecosystems as a result of timber harvest, road building. Yes, I do. Martin really threw me off here. Okay. That's the excuse that I'm going to use all night long. I'm just thinking about myself up here in spandex in front of you. These impacts may be more or less severe, but they leave ecosystems in a stressed condition that may not be as resilient to the impacts of climate change. And we'll talk some more about these environmental damages that have occurred leading up to today. We certainly are experiencing climate change currently. There's no question about it. In spite of what some of our legislators might have you think, we're experiencing climate change, and it's manifesting itself in a number of ways. Not just warming climate, as we all know, but in stochastic events of an extremity that have not been experienced previously. Although our immediate neighbors aren't necessarily hostile, we've done enormous amount of damage to our relationships worldwide. And in today's society, immediate neighbors, as would have been in Jared Diamond's book when he talked about collapse of societies, and those were ancient civilizations where your immediate neighbor had significance. In today's global economy, that immediacy or physical relationship isn't so important. We have created enemies worldwide, and we continue to do so. And specifically, we're building enemies in Central and South America, which are very close to home. We certainly have friendly trading partners. We don't have to talk about that in any detail. We're certainly exporting a lot of raw resources and importing a lot of worthless materials that we tend to throw in the trash shortly after we've used them for a short period. And finally, without a doubt, we have expressed a flawed response to environmental damage. We can think of lots of examples where we have actually had a positive and not a flawed response to environmental damage. The Clean Air Act and the Clean Water Act are great examples of that. But today, when we face climate change, we realize in our situation, climate change is directly linked to our environmental damage that we're causing. We are the cause of climate change, as opposed to, in the examples that Jared Diamond rolls out, those were all naturally occurring periods of climatic change, dramatic climatic change, that were involved with the demise of these societies. Well, Diamond lays out three flawed responses to environmental impacts. These are A, failure to anticipate the problem, B, failure to perceive the problem after it has arrived, and C, failure to even attempt to solve the problem after it has arrived. We have failed to perceive the problem as a society. We know that it's here, but we refuse to acknowledge it as a society and actually act upon the causes of climate change. And clearly, we're not effectively solving the problem as well. So in short, we have at least four, and I would argue all five of Jared Diamond's points for a collapse of society at our doorstep. And I would also throw into that mix that our sort of resistant approach to our approach of management using resistance to change is going to be part of our undoing as well. We have to be adaptive and flexible in our management of ecosystems, and that's something I'd like to talk more about shortly. In our current situation with climate change, I'd just like to go into a little bit of background on climate change before talking about adaptation of ecosystems to climate change. But in our current situation, We wouldn't be in this situation if we weren't digging or drilling fossil fuels and burning them. We know that the deforestation of rainforests, the permanent deforestation, is a significant contributor to climate change. But without a doubt, the burning of fossil fuels is the #1 cause of carbon loading of the atmosphere that is responsible for climate change, our anthropogenic induced climate change. We don't function like the rest of nature. We consume well beyond our needs, and we continue to consume when problems are in our face. Fossil fuels and the internal combustion engine, fossil fuel burning and the internal combustion engine have been a very nice experiment in convenience, transportation, commerce. It's been very effective in a number of ways and has brought us a long ways. But that experiment has shown us to have side effects and consequences that we now have to face. For example, we have addressed some of these impacts historically. For example, with the burning of coal, we addressed the particulate matter, the heavy particulate matter loading of the atmosphere by building smokestacks to put it up above cities and outside of city limits and to partially eliminate the problem. When later, when it was acid rain that we recognized was a consequence of fossil fuel burning, sulfur dioxide and NOx emissions leading to nitric acid and sulfuric acid deposition, we built scrubbers for smokestacks, and we installed catalytic converters in cars, and we were able to once again use a technological fix to address this consequence of fossil fuel burning. Now we've run up against the first law of thermodynamics. Matter can neither be created nor destroyed. And we continue to burn fossil fuels knowing that carbon loading of the atmosphere causes a greenhouse effect. Each pound of carbon that we burn releases a pound of carbon to the atmosphere. Carbon, of course, is the reduced form of carbon is the energy source that we're trying to liberate. In the process, we put carbon into the atmosphere, and we happen to combine it with oxygen, and we put about 4 pounds of carbon dioxide into the atmosphere for every pound of carbon. So we've got ourselves in a bit of a sticky wicket. We're not going to be able to come up with simple technological fixes to deal with the emission of carbon dioxide. You can't scrub out 4 pounds of carbon dioxide for every pound of gasoline or carbon as gasoline or coal that's burned. We can talk about pumping carbon below ground. We can talk about cap and trade systems. But the fundamental fact is the only way that we're going to get around the problem associated with burning of fossil fuels and the emission of carbon to the atmosphere is twofold. One, conservation of that resource, reduced consumption. Second, a rapid move away from the burning of fossil fuels and a serious search for alternative sources of energy, and specifically solar. Nature runs on solar energy. I don't understand why we think that we have to do things so differently than nature. We certainly have the capacity. We have the capacity to design and build effective solar systems. There's no question in my mind that we can do it. Nature does not burn carbon does not dig up fossil fuel carbon and burn it for an energy source. There's some examples of bacteria, of course, that will live on our chemoautotrophs and that use chemical energy. But those organisms also fix the carbon from the atmosphere, so they're actually pulling carbon from the atmosphere in the process. But nature is greatly a solar-powered system. We need to do a lot more than propose 35 mile per gallon standards by the year 2025 as a solution to climate change. We have to do something dramatic, and we have to do it now. I'd talk more about that, but that's not really the point of my talk today. I wanted to talk about climate and how the role of wildlands in our adaptation strategies to climate change. Climate change is upon us, so how are forests in the West going to respond? Well, first of all, let me talk a little bit about the value and importance of wilderness and wildlands in the West. These landscapes, these wildland and wilderness landscapes, represent several important factors. They represent refugia for native species that are stressed in managed environments and those exposed to climate change, the stressed species exposed to climate change. Wildlands or wilderness landscapes represent one of our only examples of how natural landscapes would function. We need it as a model, if nothing else, to look at how natural landscapes would function under the conditions of climate change. And finally, wildlands and wilderness serve as a safe site for clean water yields and carbon storage, among other things. And most importantly, for biodiversity of species. It's not to say that wildlands are immune from the effects of climate change. They're not. But they represent the best situation in the face of climate change for these species. How will wildlands adapt to the effects of climate change? Well, first of all, I'd like to back up, and not that you need me to define these terms, but I'd like to go through the definition of a few terms because I'd like us all thinking the same way about these, or at least discuss so that we can discuss these later on after I'm done talking. But first of all, adaptation. Adaptation is the modification of an organism or its parts to make it more fit for existence under the conditions of its environment. And this is generally associated with change. We think about adaptation when we think about change. The operative word here is change. We don't have a taxonomy for ecosystems, so we can't say, here's how this ecosystem is going to morph into this other ecosystem over time. Rather, we can only talk about these ecosystems in terms of vegetation groups or dominant species in a group. For example, ponderosa pine and lodgepole pine. So when we talk about how an ecosystem is going to adapt, we can think about it in those terms, but we really sort of need a taxonomy for ecosystems to discuss adaptation. In my title, I mentioned an uncertain future. Well, what's so uncertain about the future? Uncertainty comes from our inability to predict what's going to happen in the future given climate change. I'm going to talk more about this a little bit later on, but basically we're going to face a lot more variability in the future in the face of climate change. Models that are generated to predict the vegetation patterns in the future are only so good. They can't account for all of the variables that are going to influence vegetative patterns in the future. There's going to be an enormous amount of uncertainty about what we face with climate change, and I'll talk more about that later on. Some individuals will say, well, basically what's going to happen is we're going to lose our alpine. We're going to have this shift in species up in elevation, and we'll ultimately lose our alpine. That's a very simplistic view of what may happen under the conditions of climate change. There'll be an enormous amount of uncertainty. For example, the loss of an individual species or the introduction of a new species, a exotic species, may lead to untold impacts on the ecosystem in the face of climate change. Yet that organism may not be eliminated in the modeling process or added in the modeling process. We know that with climate change we're going to experience an increase in stochastic events such as tornadoes in Atlanta in March or hurricanes well outside the time of their ordinary season. And these these stochastic events, whether microbursts, tornadoes, or firestorms, are by nature unpredictable. So there will be a lot of uncertainty in the future. How do we manage for uncertainty? So that leaves us with the question, or the terms to define of resilience and resistance. We tend to use those two terms interchangeably, at least a lot of people do. I just reviewed a climate change report by NOAA where those two terms were frequently used interchangeably, and when asked about it, oh no, those weren't used interchangeably, you just misinterpreted how they were used. But nonetheless, they have very different meanings. Resistance is the degree to which an ecosystem or body remains intact or unmodified in the face of a stressor or an impact. Resistance implies friction or bending moment against that imposed stress. It has the potential for catastrophic failure once we get to that tipping point that has been discussed earlier in this lecture series. Resilience, on the other hand, is the degree to which a body handles stressors or impacts by changing or adapting to this new set of operating conditions. Resilience absolutely does not rule out change. Rather, change is an operable term within resilience. Resilience reflects an ability to exist in a change state or to adapt. Some suggest that resilience refers to an ability to return to original condition following a disturbance, but regardless, change is expected in a resilient system. Managed systems tend to be focused on resistance, as I mentioned earlier. If we think about dikes built to hold back waters, it's a form of resistance. You think about painting your house to resist the effects of weather, of degrading the wood on your house. There's nothing wrong with using a resistant approach to change or to an impact. It's maybe the right approach in a number of cases. But it may, again, fail catastrophically when used in the wrong conditions. Natural systems also use resistance. We can think of lots of examples of resistance in natural systems as well. If we think of low-severity fire-adapted ecosystems and that frequent fire burning in ponderosa pine forest, for example, the bark on the trees are fire-resistant, the roots are deep. That's a form of resistance to the presence of fire, not necessarily a resilience to fire, but a form of resistance. At least you could argue it as such. Resilience, on the other hand, is directly related to adaptation. Both represent a response to change or a shift in the ecosystem properties. But can we accept the shifts in ecosystem properties that are going to exist with this new set of stressors that are a result of our human activities? Unfortunately, we don't have a lot of choice in the matter. We're being faced with this impact. We're being faced with climate change, so we need to consider what ecosystems are going to prove to be the most resilient to these impacts. I'm going to use an example that's near and dear to my heart to describe the difference between resistance and resilience in ecosystems and their response to a climate change stress, and one from the past. And this one is the period of the Dust Bowl. Of course, I had to use a soils example, and I promise I'm not going to rip off the shirt, but I am going to talk about soils for a moment. During the late 1800s and early 1900s, the Great Plains were tall grass, mixed grass, and short grass prairies were rapidly being converted to agricultural lands as a result of the Homestead Act. Native fertility in these prairie ecosystems was phenomenal. People tilled these, planted them, and in Montana, average wheat yields in these recently plowed native prairies with the wheat varieties that were available at the time and the rudimentary techniques for plowing and planting were as high as they are today under heavy use of fertilizers, crop fallow to conserve moisture, and use of high-yielding modern hybrids. That's phenomenal. Why is that? Because the native prairie soil had such high biodiversity, had such high soil organic matter contents. It had extremely high water holding capacity because of all the organic matter that was present. It was an extraordinarily fertile system. That doesn't last when you plow it. The organic matter rapidly begins to decline once you start to plow that landscape. And I don't have time to go into the details on why that is, but safe to say that you lose about 50% of the carbon especially the bioavailable carbon in the first 10 years after the landscape was plowed. Okay, so these agricultural lands were running on this extreme high fertility. But in the late 20s and early 30s, they experienced 3 waves of very severe drought. In the process, crops began to fail. The response by the farming community was simply to pick up, plow, and plant once again, was using the same techniques and the same approach as was used the year before. Now with the depleted organic matter, the lower water holding capacity, the combined effects of drought, and the presence of a pest outbreak, in this case grasshoppers and Mormon crickets, pest outbreaks where these organisms thrived on this monoculture of wheat, the crops failed over and over. Once you had failure and drought and wind erosion, it's a snowballing effect. You lose more topsoil every year, the fertility declines, the water holding capacity declines. I don't need to go into any more detail. It was catastrophic failure. People left the West in droves, and Montana is a good example of that. In contrast, the native prairies that were not plowed were highly resilient to those 3 waves of drought. And the reason for that was the high biodiversity that exists within the planted within the plant ecosystem, because when the grass has suffered from the effects of drought, the forb productivity maintained a relatively constant level. So the system was resilient to that impact of drought. It was resilient in terms of, it wasn't the exact same ecosystem as it was before. As I said, grass productivity was greatly decreased, but the ecosystem as a whole was resilient and survived just fine. As a matter of fact, if you went back to those landscapes in the 40s, you wouldn't be able to tell that they experienced dramatic drought years in the 30s because of the condition of the prairie. Diversity improves the stability, generally improves the stability of ecosystems by providing by providing a buffering effect to climate change. And it does so by having depth in different functional groups. We simply have organisms that are capable of stepping up in the face of that change and filling those functional roles when a species that is not capable of handling those conditions declines. Although the players change, the overall ecosystem continues to function and function naturally. So what's a parallel in our forest ecosystems? Can we think of a parallel in our forest ecosystems currently? If climate change leads to increasing occurrence of fires across the landscape, what will work better? An approach of resistance, like the farming community, or approach of resilience? Resilience would mean allowing fires to burn in those less managed landscapes far from communities, and controlling fires only near communities and around communities where we have lives at stake and property at stake. Resistance, an attempt to stop all fires across the landscape, will first of all bankrupt the Forest Service, and second, it won't work. because we can't possibly suppress all fires in a condition, in a climatic condition as which we're facing, as which we're beginning to face now. Between 1948 and 1988, we averaged about 2 million acres of wildfire in the West a year. In the last several years, we have averaged over 6 million acres of wildfire in the West. And this last year, I think the total was actually in excess of 9 million acres of wildfire in the West. So climate change is occurring, and fortunately for natural ecosystems that are not constrained by the demands of society, change is a given, and these ecosystems will adapt to these changes. Climate change brings with it a host of direct and indirect impacts to our forest ecosystems. Already in this series, Dan Faegre has talked about the impacts of climate change on the glacial retreat in our mountainous ecosystems, and the impacts that this has on our fisheries and changes in stream temperatures in riverine ecosystems that are fed by groundwater as opposed to fed by glacial melt and snow melt. Steve Running, a couple of years ago, gave an excellent talk in this series on climate change and how the impacts of climate change on wilderness landscapes and our mountain landscapes. In spite of the great ski season that we're having this year, and everybody's been talking about how this is an example of global cooling. I've seen about 4 letters to the editor in the Bozeman paper that describe global cooling that we're experiencing. This is only 1 year in a trend of 30 years of warming conditions. We've been experiencing lower snowpack in high elevations, and again, that has direct impacts on our rivers and streams and on the fisheries that those support. Forests are experiencing increasing occurrence of fires, especially in mid to high elevation in ecosystems, and this impact has been people have attempted to tie these impacts to fuel loading and to increased stand density, which certainly plays a role, but climate is the primary driving factor that has resulted in this increased occurrence of fire on these landscapes. Disturbance in terms of fire is a given in these forest ecosystems, and we have to accept that fire is going to be common in the West. However, the frequency and timing of these events is going to be different, and the impacts on the landscape are not clear. Those ecosystems that are going to be most at risk are going to be the ones that are at the edge or at the boundary of their range. Wilderness landscapes, as I said earlier, provide refugia from non-climate stressors such as human incursions into these wilderness areas, reduce connectivity of landscapes, water pollution, thermal pollution. However, in the case of wilderness and resilience, as it turns out, size does matter. We know that wilderness landscapes tend to be islands in the lower 48 states. A recent study that was done by the Nature Conservancy suggested that the only ecosystem in the lower 48 states that was large enough to be protective of species in the face of climate change is the Greater Yellowstone ecosystem in the Crown of the Continent. That's a pretty disturbing thought. This means that our wilderness landscapes are not 100% going to be resilient to the effects of climate change, because we have to have we have to take into account size. When I say size, I'll just back up for a minute and refer to a study or a report that was written by Reed Noss, who indicated that the species extinction could be minimized during climate change by giving species an opportunity to adapt. And adaptation to climate change can come through, he suggested, through phenotypic plasticity, adaptive evolution, or migration to suitable sites. That migration to suitable sites assumes would require connectivity of the landscapes and require large sizes of naturally functioning landscapes for those organisms to be able to move to those suitable sites. Jennifer Beringer with the World Wildlife Fund took this detailed report that Reed Noss had provided the World Wildlife Fund and prepared a very nice synthesis on resilience and the management of forest ecosystems to maximize resilience. If you were to take her primary points within that article and sum it up, you'd say what the most resilient ecosystem would be, or the most resilient managed body would be, a very large wilderness area. So just to go through the several items that she identified as being proper management approaches to increase resilience, she mentions the need to avoid fragmentation and maximize connectivity, the need to maximize the size of management units for the migration of species, as mentioned previously, to provide buffer zones surrounding these wilderness or wildlands with well-managed forest and rangeland ecosystems, represent forest types across environmental gradients. In other words, wildlands that function naturally from grassland to alpine. Protect mature forest stands, in other words, and stressing the importance of old growth. Protect functional groups and keystone species. Protect climatic refugia, in other words, topographically diverse areas, and maintain natural fire regimes. There was a number of more management-specific points that she described in her article, but those are the ones that relate directly to wilderness. Unfortunately, our wilderness lands in the lower 48 are a little bit like islands, and that makes them more susceptible to the effects of climate change. Larger protected areas will be more likely to have full representation of forest ecotypes that would span those environmental gradients. These islands of wilderness landscapes are simply not enough. So am I here today as a member of the Wilderness Society to say, let's designate the whole West as wilderness and that'll save us from climate change? And the answer is absolutely not. That's not my point. But rather to ask the question, how are we going to deal with the lack of resilience on managed lands and have those lands function in harmony with our wilderness lands to maximize resilience? In particular, our low elevation forest ecosystems and our and our grassland ecosystems are those that have suffered the most at the hands of land management over the last 100 years. Specifically, our ponderosa pine, Doug fir, sort of dry forest ecosystems were heavily hit by timber management and have been heavily hit by fire suppression. That's where the wildland-urban interface exists, and that's where the majority of fire suppression efforts end up taking place. We also have our prairie ecosystems that very few people stop and think about. You know, people get really upset in the thought of timber harvest activities, but very few people stop and lament the fate of the Great Plains prairie, which is an equally beautiful landscape, an equally important landscape that we've greatly forgotten about. These lands will prove to be very important in resilience of the West to the effects of climate change. So how do we get there? We've discussed a little bit about land preservation and the role that these wilderness landscapes play. How are we going to maximize the size of these wilderness units. One possible approach is conservation easements, and there's been a lot of effort being put that way just in recent history here in Montana with land trusts and the Nature Conservancy. And that's a great approach to leading to more conservation-based management of those landscapes. But another approach is to encourage the natural management of landscapes on private lands and on working lands, on working landscapes. Here, our vision is that healthy communities maintain healthy forest and grassland ecosystems and help conduct the restoration of disturbed grassland and forest ecosystems. Our vision is that these communities will have a restoration of the land ethic within these communities, and that there'll be a conservation strategy for every acre of land in these valleys between wilderness landscapes. This may not be realistic, but that's a vision and a dream. We're currently working with certain groups where that seems to be coming true, and one example of that is the Blackfoot Valley and all of the restoration and conservation efforts that are going on within that region. Our hope is that by working with these groups and by working in a landscape where those politics work to where communities embrace this restoration concept and embrace this idea of have a shared vision for the natural management of whole landscapes, then we may have an opportunity for these very large natural landscapes, management of these lands as natural landscapes. When I started with TWS, I had a hard time with the term restoration. It's not a term I use lightly. I don't believe that we can really restore disturbed landscapes to a historical condition. Number one, I don't really believe that we have a really solid idea of what that historical condition was. And I don't think that we can get back there, and especially under conditions of a changing climate, we may not belong back there. So I always had a hard time with that concept. But I think now more in terms of restoration, more in terms of restoring of natural processes, not trying to restore the specific structure and function or the specific structure of a historical image that we hold in our minds, but rather trying to maximize those natural processes that we know should function on that landscape. That is how at least I'm looking at restoration. And I also see restoration ecology, people that are working with communities and with land management agencies to restore these landscapes, that I see that as a mechanism to restore the land ethic within communities. And the reason why I say that is that when communities are engaged in that way, engaged in the restoration effort, that then they take stake in it and they take it seriously and they recognize it as their landscape as well. Even if it's on public lands, they very much take ownership of that. And it is ours, it's not theirs, does belong to us. Wilderness is not going to stand alone as rock and ice. In other words, we have most of our wilderness landscapes are the high elevation landscapes, and we desperately need the low elevation landscapes as part of that naturally functioning land. I think that restoration is a way that we may partially get back there, but only if we use an adaptive approach to that land management or to that restoration. Adaptive management is a term that's used a lot, and it's not taken very seriously, I don't think. Most of us have heard the term and we've talked about it in classes, and that is the cyclical and iterative process of evaluation, planning, implementation, and monitoring. Is it being conducted on landscapes today? Not greatly. Maybe in isolated situations, but rarely is adaptive management really conducted in a way that it's supposed to be? The reason why I say that is I can give a great example of it right now. Stewardship contracting is one approach to handling these timber management operations in the West, and the money that comes from the timber harvest goes into restoration within that same area. And within the pilot program for these stewardship contract projects, when that was rolled out about, about 8 years ago or so, the pilot programs had required monitoring within those. I went and looked into all 22 stewardship contracts that were conducted in Montana under that pilot program, and 2 had submitted monitoring reports. That's not to say that no monitoring was done, but 2 had finalized monitoring reports. And of those 2 monitoring reports, both were what are called implementation monitoring. Implementation monitoring is where you monitor the site to determine whether or not the project was actually conducted on the landscape, to look and see, was it actually laid out. It is not ecosystem or effectiveness monitoring. That hasn't been being conducted, and it's not the fault of the management agency because they don't have a budget to conduct that type of monitoring. But monitoring is absolutely fundamental to adaptive management. And we're not going to get there, we're not going to get to adaptive management if we don't have monitoring as a part of it. We don't know the trajectory of our restoration efforts if we're not monitoring the outcomes. So how are we supposed to respond to it and correct our activities if they go awry? So monitoring is going to be extremely important in this adaptive approach to management, and something that absolutely needs to occur if we're going to effectively manage these ecosystems. Let's see, I'm running a little behind here, so I'm going to go ahead and skip a discussion on forest restoration at low elevation landscapes and leave that for a discussion afterwards, because that's the most common form of forest restoration that's been conducted in Montana, and something that might be worth discussing in a little bit more detail. I think, in the interest of time, I'm going to simply say that monitoring can be viewed as one of the really fundamental ways that we can engage the community in that restoration effort and engage the community in that land ethic. Monitoring by multi-party teams made up of community members and timber industry individuals and agency personnel and environmental groups can effectively work together to conduct some of that monitoring, but it has to be bought into by all members. And so with that idea in mind, I'm going to go ahead and just jump to some concluding remarks, because I'm up to about an hour now, and say that to reiterate, change is one of the only constants in nature. Ecosystems are going to shift with these climatic changes. They have for millennia. They'll continue to shift. This is indeed a form of resilience. They may not shift the way that we want them to shift, but these ecosystems are going to handle themselves just fine in the long run. That's not to say that that means that climate change is okay. That is to say that we're not going to be able to stop that shift. All right? Degraded, fragmented ecosystems are going to be a whole lot less resilient to the effects of climate change than our natural ecosystems. And as I said, large ecosystems are going to be the large intact ecosystems are going to be the most resilient. In my opinion, we basically have 5 important options that actions that we need to take to protect these landscapes and to address the effects of climate change. The first and most important is to stop the hemorrhaging. Even if we need to absolutely act on climate change now. The efforts that are being conducted by our government are laughable. They're absolutely laughable and ineffective. It's up to us as citizens to take action ourselves. And that means reducing fossil fuel consumption as dramatically as possible and demand alternative energy sources. We are being held hostage by fossil fuel interests. All right? All other reactions to carbon emissions outside of stopping the burn or slowing the burning of fossil fuels and looking for alternatives are going to be minor, relatively minor and insignificant. For example, things like if we attempt to plant forests to offset carbon emissions by fossil fuels, we're talking about the emission of carbon that was buried below ground and would have remained below ground for millions of years. And we're trading that for carbon stored in a forest or stored in a soil for tens to hundreds of years. There's no comparison, all right? The solution is to stop the burning of fossil fuels. Even once we stop, we've got many, many years before we get things under control in terms of the shift that's taking place in our climate. Second, we need to protect large intact bodies of land and manage landscapes that are in association with those large wildlands in as natural an approach as possible. We need to attempt to protect those landscapes from anthropogenic stresses. Obviously, we can't protect them from all the impacts of anthropogenic stresses that exist, but nonetheless, we need to try to protect them as much as possible from our activities. We need to restore degraded ecosystems using an adaptive approach. Focus on the restoration of second growth forests, not old growth forests. Focus on old growth forests simply as a protective approach, reducing ladder fuels that might cause the catastrophic burning of old growth trees. But we should be focusing our restoration efforts on those second growth forests that were hammered in the last 50 to 100 years. All mature trees should be protected under the old growth trees should be protected. Restore degraded lands, restore the degraded land ethic in communities and access this through restoration activities, possibly at least restore this through restoration activities. All people live in Montana, or at least most people live in Montana because of our love of this landscape. We're not getting rich here, at least not many of us are. We live here because we love the place, and we can play a major role in the restoration of these disturbed landscapes. And finally, improve management of existing wilderness landscapes to protect those landscapes against incursions, better trailhead management, use of restoration of degraded landscapes degraded by excessive recreational impacts. This is something that TWS has not been greatly engaged in the past, and something that we need to be more engaged in is protecting the wildlands that we have designated as wilderness. These wildlands will ultimately adapt to climate change, but the question is, can our society adapt to climate change, and what can we do to ensure the adaptation, to ensure the adaptation of these natural landscapes to the effects of anthropogenic climate change. With that, I'll go ahead and tie it up and open it for a discussion. Thank you. Any questions or discussion? Yeah.
I'm interested in your comments on monitoring restoration efforts. Can you give me some examples of what, if you've got a restoration project, what should be monitored, what kind of data should be collected, and I'm thinking in terms of both citizen science monitoring or any other specialized monitoring that require more training. How do you do that effectively?
Yeah, so the question is what types of things are you going to monitor in a restoration effort, and to have meaningful data that will be useful in determining the trajectory of your restoration activity. And of course, it's greatly going to depend upon the ecosystem that you're restoring or attempting to restore. And the types of things that you're going to want to monitor are things that your budget can handle, for one. So that sounds like a silly place to begin, but it's really important. The Forest Service greatly can't afford monitoring at a detailed level on many restoration projects because budgets spiral out of control if you have scientists out there collecting data on a regular basis. So it has to be something that your budget can handle. And secondly, it has to be something that is reliable, that is a reliable variable to measure, that is quantifiable, that is something that you can, ideally it would be variables that could be measured by a variety of individuals. That's not something that has to be measured by specialists. There's going to be examples of things that can only be measured by specialists. And for example, monitoring of endangered species, and that can be handled by the agency itself. But in terms of multi-party monitoring and engaging as many people as possible, we want to have it something that's simple, that's doable, but something that is repeatable, that is defensible, and that is quantifiable. So to give you some examples of that, like in a forest restoration activity, and one of the simple things to monitor would be invasive species. That is something that any individual can monitor for, it can be quantified, and it is a direct impact of the management activity, and it has very significant implications. Another thing that can be monitored is change in stand characteristics or stand attributes with time after, and not just stand volume or stand, but also things like mortality. Those are things that can easily be quantified by a citizen scientist. We're working on a project right now where we're trying to come up with simple soil monitoring variables, because soil is, of course, the fulcrum for all living things, right? And it's the, no, just kidding. But the soils are extremely important in the environment, and some variables can be easily measured by citizen scientists. An example of that would be every high school has a muffle furnace, right? And a scale. And so high school students could easily measure organic matter contents in soil. And that's a really important ecosystem variable that changes with management. Another important variable that could be measured is degree of compaction and infiltration. Infiltration is actually a very sensitive measure of compaction, and it's easily measured, and something that could be measured by any multi-party team. So those are just a couple of quick examples, and I could go into other examples as well, but does that answer your question relatively well?
I'll talk to you later.
Okay. Yeah, Lauren?
Tom, in talking about resilience and reaching resilience through restoration and focusing restoration on processes rather than structure. In the grassland ecosystem, what does that look like to restore processes? I think we're so tuned into our forests, but
right.
I'm curious about that in the grassland setting.
So to restore processes in a grassland, of course, again, I'm going to be so soil focused, but example of restoring processes is restoring the activities of organisms that result in that result in a product. For example, and this isn't something that you'd monitor, but restoring nutrient turnover, restoring carbon incorporation. Grasslands feed the soils with carbon. A grassland actually loses about 20% of its total photosynthate below ground during the growing season to root exudates and sloughing off. That is a huge carbon influx into the soil on a day-to-day basis. And that is ultra important in a prairie environment for maintaining all the bioactivity that has this feedback effect on the plant community. In a agricultural setting, that is greatly reduced because of the density of plants is so greatly reduced, and you also reduce it to one species. You harvest the most valuable part of the crop in terms of the plant, in terms of the grain. So you take away the majority of energy that's been produced by that plant and you pull it off site. And so you have much less recycling in it. So it's that change in cycles that exists. So elimination of these cycles that would be an example of a process that you'd want to not have occur. You want that process to be maintained. Is that a decent response? Okay. Yeah.
How has your role and your duties in these issues changed since you left academia for the private sector, and what has the different involvement been?
In terms of research?
In terms of how you orient your work?
That's a great question. As an academic, you're very much focused on your own research area. It's a personal thing. You may have greater objectives that are related to things that you want to see on the lands, research that you think is important as an ecologist, but it's very much a personal relationship between you and your research. It's very selfish, actually. No offense, I'm an academic still, and research is selfish. You're very focused on your own area, and it builds upon itself. When you conduct research as an academic, you're thinking about, how am I going to publish this? Is this going to lead to another grant down the road to support more work in this vein that I'm going to? So it ends up being somewhat of a selfish endeavor. As a researcher in a organization, I'm in a nonprofit organization, not private sector, but in this group, my research has to be useful to this larger organization. It's not just me and my work, but it has to be a part of this collective effort to build knowledge within a given area. So that's a really significant difference between the two. Another difference between the two is I'm not allowed to apply for grant money. So it really changes the way I think and the way that I pursue things. I operate on money that other people really apply for. I'm involved in a little bit in that process, but more at the stage of my research results are used in other people applying for foundation money. So I'm removed from that process, and that's a huge difference. Here at the university as an academic, you're constantly spending time and effort searching for money. It's probably 40% of your research time is devoted in one way or another to applying for additional support. That may be a little bit excessive, maybe 35%, but it's surprisingly high percent of your time spent on searching for money. So that's a difference. Other differences are, as an academic, of course, a lot of my efforts go towards teaching. And I'm not teaching anymore. I think that showed tonight I'm a little rusty. But I'm not teaching anymore. But instead, my teaching is different. I do a lot of outreach through writing, through op-eds. I've written numerous op-eds by now. I do a lot of writing in sort of mainstream type literature, and in addition to my research, it's a new type of teaching that's outreach to the community. And so that's a major difference as well. Yeah. Thanks for the question. Yeah?
Tom, my question is regarding the wilderness in the United States is obviously an asset that we need to protect, not just for the United States, but for the rest of the world. But as far as climate change is concerned, this land is not as desirable in helping climate change as something in, say, the tropics. And it's a lot cheaper to buy land there, too. Well, do you think that our time would be better spent logging this, taking that money and investing it in the tropics? Or, that's a bad example, but you get my point.
Yeah, I definitely get your point. I think there's better ways to protect the tropics than to log this area to pay for the. And, I think that you're absolutely right. The productivity, the carbon storage, the biodiversity in those landscapes is phenomenal and needs to be protected, and we should be spending more effort on protecting those lands. That's not to say we shouldn't protect the wilderness landscapes in this country. And I think that we need to realize these things are all interconnected. It was pretty much of an eye-opener to a lot of people to see that. I've been working on biofuels for years. We published our first paper on being critical of the corn ethanol industry back in the early 90s. And a lot of people thought, why are you critical of this? This is a green fuel. This is a alternative fuel that reduces the use of fossil fuels. But very few people had any idea of the long-range implications of expanding that fossil fuel production. The reason why I'm mentioning this is because that's one of the links to deforestation of tropics, is that we're putting so much strain on the by producing so much grain ethanol, we put a strain on the soybean industry, which results in greater soybean production in the so. There's lots of other ways we could go about protecting tropical rainforests, and it's pretty surprising when it's things like being piggy and consumptive on fossil fuels leads to us thinking that we're going to make a stand with grain ethanol, and that ultimately has this impact. So I guess my point is that there's a lot of other ways to address it. We don't need to it's not timber production that's leading to the demise of the rainforest. It's a number of other things. And I do think that we should be bioregional in our wood consumption. I do think that there is absolutely a role for wood production in Montana and for timber production in this region. And I think we absolutely need to have a healthy timber industry within our state. Are we going to import wood from China? Are we going to import wood? We go to Walmart and buy these chairs. I don't go to Walmart. I've never been to Walmart in my life, actually. But our tendency is we want to buy inexpensive furniture. It's available at Walmart. It comes from exotic wood from overseas. It's crazy. We could build beautiful wood products using wood sourced regionally, and do so in an environmentally sensitive and sound way, I think.
You mentioned that natural ecosystems will, adapt to climate change. But I'm wondering, what do you think will happen ultimately to our own species? I guess say within a century, if we continue to resist climate change.
We're doomed. No, honestly, I don't have I think if we don't act very soon, we're in a lot of trouble. I think we're in a lot of trouble. We're in more trouble than we recognize. And I don't know how long it's going to be, if it'll be 20 years, 30 years before we really are, as a species, are sort of running for our lives and wishing we had acted 20 or 30 or 40 years earlier. But I think that we're pretty dang clever animals at the same time, and we find ways to deal with situations. I just don't think that I like the thought when I imagine how we might survive in the future under conditions of extreme climate change. It's not a pretty thought. I'm sure most of you have seen the movie Blade Runner. Have you seen the movie Blade Runner? Thriller movie? When I first saw it, I thought, oh, that's a good thriller movie. That's a great movie. There are some incredible scenes in that movie. And one of them is that it's always raining. It's never not raining. And it's because of climate change. It's because of long-term climate change. Another thing, I mean, there's some really incredible social messages in that movie as well. And it's definitely worth looking at again. And get the one that has the voiceover. Don't get the director's cut where they took out the voiceover. The voiceover is awesome. Okay. It sounds really trivial, but actually it is a good movie, and it has a number of really important messages in it. And that's one of them, is that the wealthy live elsewhere. The rest of us live in the climate-changed environment that is hanging on. We live with the clones, so. Yeah.
Regarding forest management plans, if you have managed ecosystems, it's obviously need to consider more than just historic range variability. But what quantifiable forest processes, other than fire, really obvious, can they use to write a plan with and say we're going to manage to maintain these processes for the future and have it incorporate the new knowledge about climate change?
Yeah, that's a great question. Let's see, I don't know if I can come up with I'm going to defer to David Cole. No, I don't know if I can come up with a great answer to that. That's a good question. So fire is the classic one. It's the one that we can all see and that we can all relate to. There's a number of other processes that we could describe or discuss. And again, my tendency is to look at turnover, nutrient turnover, carbon turnover within the ecosystem, and that is a process that one could watch. Another would be shift in species composition. And really important is going to be, we have introduced, or are at least one of the vectors involved in the introduction of a lot of species. Under these change conditions, these exotic species may go haywire. And so I think that exotic species monitoring is a really important factor in these forests. Water relationships would be very important. When we look at forests and we see that branches are losing needles, and trees are retrenching given the water limitations that exist. There might be simple ways to look at water limitations besides doing sap flow measurements or something like that. But those would be some examples of things that I would imagine that we could look at. I could go into others if you want, but do you have any ideas? No? Things that you would look at? Okay. Other questions?
I have a question.
Yeah, Mark.
You talked about some of these large wilderness ecosystems like Crown of the Continent and the Greater Yellowstone ecosystem potentially being resilient to climate change. But this is a two-part question. One is, even in those ecosystems, are you worried about loss of biodiversity in the face of climate change? And if so, do you think we should be actively managing those landscapes, like moving things around, assisted migration, or thinning forests to increase resilience to fire? Do you think those are appropriate activities in protected lands, given the face of the threat?
Okay. The answer to the first part of the question is that I do think that diversity is at risk in these landscapes in a number of ways. And I tried to make that point, maybe not very clearly, but that wilderness landscapes are absolutely not immune to the effects of climate change. They're absolutely going to be feeling the effects, and species diversity will be directly affected and indirectly affected. And again, I don't mean to keep coming back to invasive species, but that's just one example of, under those changed climatic conditions. And there's some super plants out there that we haven't even talked about in the state yet that make knapweed look like a joke in comparison. Okay, so the answer is yes. The second answer to the question is should we do assisted species migrations and that type of thing? My feeling is that should only be done in pilot projects with intensive monitoring, if done at all, because the likelihood of going wrong, getting it wrong, and pursuing it so far down the track before we realize that we've gone the wrong way with this is very likely. We have such a great history of having right intentions and doing the wrong things that that would be a classic example of it. So if that were to be done, it should be done very much in pilot, and perhaps instead of going into the heart of the GYE or the Crown and doing this, is doing it in wilderness study areas more at the margins of these large intact landscapes. So that would be my thinking on that.
Any final questions? We've got one.
What role do you see for protection of smaller areas as part of the formula here, like research natural areas on the national forest, or conservation uses, or those kinds of
In terms of the role that they play, or in terms of how do we protect them? I guess I'd...
More the role. Do you think they have a contribution?
Yes. They absolutely do have a contribution. They have a contribution in a number of ways. And maybe I'll just go back to an example from my PhD, because I did my PhD in Iowa and wanted to study natural systems. So that's kind of a funny place to go to study natural systems. But I wanted to contrast how native prairies function compared to agricultural landscapes. And finding native prairie remnants in Iowa was extremely difficult, but was able to track down quite a few. They were small, but they maintained enough of these natural processes that we have been talking about tonight, that I discovered a number of very interesting things to myself discovered that I would have never known by not having those landscapes or by not having those protected areas. As small as they were, they provided a wealth of information, and a number of people have followed up on those studies and have continued to use those remnants as paired contrasts with agricultural lands. And those are very small. Those are 20-acre prairie remnants, as opposed to these research natural areas being 1,000-acre research natural area or 2,700-acre experimental landscape or something. So they play an important role from that perspective of that mirror into the or window into the past that I mentioned earlier. They also play a role in terms of biodiversity hotspot. Those prairies had approximately 2 times the total microbial biomass of the agricultural soils. That's just total biomass. The majority of the species that are present in the agricultural landscapes can be tossed into 3 broad groups. The diversity of species within the prairie landscape was incredible. What role might they play in long-term sustainability of that landscape as a whole? I have no idea, but having that biodiversity hotspot is extremely important. It's also a source of native seed. It's a source in terms of those prairie remnants. It's also a refugia. Even as small as it might be, it's an important refugia for species. So I think there's a lot of, I didn't mean to say that the small landscapes weren't important. I just wanted to emphasize that large intact landscapes and large naturally functioning landscapes would be really important in terms of resilience and allowing species migration and that type of thing, given climate change and the shift in species composition with climate change.